everyone. Today we're going to talk about translations on the coordinate plane. So translations are a type of transformation. A translation is a slide. There are two ways to denote translations. One is by mapping. So our mapping notation is that we say x comma y goes to, and we would say x plus a, y plus b. And that's not only called mapping, but that's also function notation. The other way we can say it is by vector notation. So vector notation, we use these pointy parentheses, and we would say a comma b. And that would also move it by A and B. So what does this mean? So when we're looking here, we have square ABCD, and it's mapped. That's what that arrow means, is mapped to A prime, B prime, C prime. So how did we move this? It's a translation because all I did was slide. So yes, it's a slide. So to describe the translation, we want to figure out how we moved it. So we moved all the points the same distance because you can see it's still a square, still the same size. So I can pick a point. So I'm going to choose B. So I moved B 1, 2, 3, 4, 5, 6 right. And I went down 1, 2, 3. So we could describe it by 6 right, 3 down. Now the better way to describe that is using either our function or our vector notation. So our function notation, we would say that x comma y went to. Now 6 to the right on our coordinate grid is adding 6. So that's x plus 6, because to the right is plus. And then we went down, which is minus, so it's y minus 3. The vector notation is I use the pointy, and I do 6 comma negative 3, because I went down. Now if I would have gone left, that would have been negative. So let's look at this example. So I want you to pause. I want you to plot this triangle and then come back. So I plotted my triangle, ABC, and now I want to graph the image along the vector negative 4, 1. So negative 4 means left 4, and positive 1 means up 1. So we can do it graphically by taking each point. So C, I'm going to go left 4 and up 1. And C prime is therefore at negative 5, 4. Do the same thing with B prime. So I'm going to go left 4, up 1. So B prime is at negative 1, 4. Now A prime, I could continue to count, but I can also notice that really what I'm going to do is I'm going to take 2, I'm going to do minus 4, comma 1 plus 1, and that gives me my new point, negative 2, 2, which if you can see is left 4, up 1. So I can do this by graphing or by adding and subtracting x and y, because a translation is always a slide, which is always adding and subtracting x or y. A third way to denote the translation I've done right here, which is using a capital T, and then I write in vector form what it did below. So 3, negative 1 means the x value changed by 3 and the y value changed by negative 1. So I want you to pause and I want you to do A, B, and then we'll come back and do C together. So you can see I plotted my original triangle A, B, C, and then I performed the translation of 3, -1 to get A prime, which is 0, 3, B prime, which is the point -1, -2, and C prime is 1, 0. Now I want to draw the vector that defines the translation. So to draw the vector that defines the translation, I'm going to pick whether I'm going to use A, B, or C, and I'm going to draw a line from A to A prime. Now, when I draw this line, I put an arrow on the end because that indicates which direction. So that shows me that I went right 3 and down 1, which is the vector 3, -1. And I can do that from any of the points, and you'll notice that they're all parallel. And that's how I draw the vector. So our last example, I believe, nope, we got a couple. Okay, so we got a couple more problems to do. Sorry about that. So number 3, in the diagram below, AB is drawn. Point A has been mapped to A prime by the use of a translation. Find and plot the coordinates of B prime, the image of B after the same translation A underwent. State the coordinates. So what I'm going to do is if I look from A to A prime, it followed this vector, which is up 3 and over, up 3 over 6. So I'm going to do that same vector on B. So I'm going to go up 3 and over 6. And here's my coordinates of B prime, which is 9, -1. Following that same vector, because when we do a translation, every point moves along the same vector. Was the relationship between AB and A prime B prime? They are congruent because translations are rigid motions that preserve distance. Preserve means keep. Number 4, under a given transformation, 3, 3 is 6, 1. Using the translation, find the pre-image of each of these. So if I went from 3, 3 to 6, 1, my x coordinate added 3, and my y coordinate subtracted 2. So the vector of translation is 3, -2. Now I want to know the pre-image. So what that means is this is my image. So that means I'm following the vector backwards. So instead of adding 3, I'm going to subtract 3. So that becomes 5. And instead of subtracting 2, I'm going to add 2. So the pre-image of 8, 3 is 5, 5. I want you to pause, and I want you to try question B. So again, since I'm looking for the pre-image, instead of adding 3, which is the vector, I'm going to do the vector backwards. So I subtract 3. So I get -1. And again, instead of subtracting 2, I'm going to do that backwards, which is adding 2. So it's -1, -3. 5. Sometimes a figure has had multiple rigid motions combined to produce an image. Given the two triangles shown in the image below, describe the series of rigid motions that would map ABC onto A prime, B prime, C prime. There are several correct answers. So we will actually discuss this one in class tomorrow. If you have any questions, please ask me in class.